Here we have a curve. We'd like to estimate the area under this curve between certain limits, but it may well be that the function is one that we cannot integrate. So we need an approach to find the area. The approach that we're going to use is called the trapezium rule, and it will give us an estimate of the area under a curve in a case where we don't know how to integrate. Suppose we want the area between here and here. What we do is separate the area into several different trapezia, all of which have equal widths. So this point we'll call A and this one B. The width of each of the trapezia is the same, and we'll call it H. To calculate H, we can do B take away A divided by N, where N is the number of trapezia or intervals that we're going to use. On our sketch below, we can see that we've used 4 trapezia. So here it would be B minus A divided by 4. Let's consider the area of a trapezium. We know a trapezium is a quadrilateral that has 2 of its sides parallel. So here are the parallel sides. If the lengths of the parallel sides are called A and B, then the area of the trapezium is given by a half of the sum of the parallel sides times the distance between the parallel sides, which we can see as h in the diagram. We're going to approximate this area using these 4 trapezia. To work out the area, we need the lengths of the sides. The length of this side is going to be the same as the y-coordinate of the points shown. The same here. This y-coordinate is the length of this side. The same here. The same here. And finally here, this y-coordinate gives us the length of this side of the trapezium. If we call the area of this trapezium A1, then following the formula, A1 is going to be a half. The lengths of the parallel sides are y0 and y1, and the distance between them is h. For the second trapezium, the area is A2, and it's a half y1 plus y2 times h. This is A3. Area 3 is going to be a half. The parallel sides are y2 and y3. And the distance between them is h. A4 is going to be a half. Parallel sides are y3 and y4. And the distance between them is h. The area under the curve is going to be approximated by the sum of the areas of the trapezia. So the total area under the curve is approximately equal to A1 plus A2 plus a3 plus a4. And this is going to be equal to a half of y0 plus y1 times h plus a half of y1 plus y2 times h plus a half of y2 plus y3 times h plus a half of y3 plus y4 times h. If we look at this expression, we can see a common h and a common half, so we can take out a factor of h over 2. If we then open the bracket, we have y0 and y1, y1 and y2, y2 and y3, and y3 and y4. So we have h over 2 into, we only have the one y0, and we have 2 of the middle y's. So we have 2 y1s, 2 y2s, and 2 y3s. But only the one y4. And this will always be the case. We only have one of the first y and one of the last y. So if we used n trapezia, our formula would generalize to give us that the area can be approximated by h over 2 times y0 plus twice all of the middle y's, y1 add y2, all the way up to yn minus 1, and then a yn on its own, just like this.